All right, the next step has two parts. So we're going to look at step 4A first of all, which is finding the p-value. So first of all, we have to go back and look at our alternative hypotheses to see which type of test we have. So we're just looking at the inequality in that hypothesis. So if it's a less than, so if it points to the left, then it's a left-tailed test. If it's a greater than, which points to the right, then it's a right-tailed test. If it's a not equal to, then it's a two-tailed test. So this is really pretty easy. You can just look at which way your inequality is pointing to tell you which tail you've got. Or if it's a not equal to, then it's two-tailed. Then we need to draw a picture of the distribution and plot the test statistic on that distribution. And this doesn't have to be perfect as long as you're getting the major idea of what the distribution looks like and basically where the test statistic is. And remember that the z and the t distributions both look very similar. They both have a 0 in the middle and they're symmetric on either side. But the chi-square distribution is quite a bit different. Okay, and then we want to shade. So for a left-tailed test, we're going to shade the area to the left of the test statistic. For a right-tailed test, we're going to shade the area to the right of the test statistic. And for a two-tailed test, we're going to shade whichever tail the test statistic is in already. So if it's in the right tail, we're going to shade to the right. If it's in the left tail, we're going to shade to the left. And then to find our p-value, we're going to find the area of the region that we shaded. So be sure to use the right distribution in this one. So this is where you need to go back to the formula you had for your test statistic and pay attention to whether you had a t or a z or a chi-squared on the left side of that test statistic. That will tell you which distribution to use. And one final thing with this, if you had a two-tailed test, then you need to multiply the area you find by 2 to get the p-value. Here's an example of finding the p-value. Here was our alternative hypothesis. It was that mu was less than 195. Since that's pointing to the left, that means that this is going to be a left-tailed test. Our test statistic that we already calculated from step 3 was t0 equals negative 2.05. So then we need to draw a picture of our t distribution. So here's a basic t distribution. It has 0 in the middle. We're going to plot our test statistic. So since this is negative, that means it's going to be to the left of the middle of this. And then since this was a left-tailed test, we're going to shade to the left of our test statistic. So then this shaded area is the area we want to find for our p-value. And if you're doing a t distribution, you're going to use n-1 degrees of freedom. So on your calculator, you can use the t-CDF function. So since it goes all the way out here to the left, we're going to use a big negative number for our lower bound. We're using our test statistic as our upper bound. And then our degrees of freedom is n-1. Since our n was 120, our degrees of freedom is 119. So this comes out to be 0.0213, and that's our p-value. Since this was just a left-tailed test, we don't need to multiply this by 2. It's just exactly the area that we found. For this hypothesis test, our alternative hypothesis was that sigma is greater than 3.2. Since that's pointing to the right, that means this is a right-tailed test. And our test statistic that we calculated from step 3 was that chi-squared is equal to 70.58. The chi-squared here tells us we need to use the chi-squared distribution to find our p-value. So here's a picture of our chi-squared distribution. Remember, it looks kind of different than the other two. It actually starts over here at 0 and just goes off to the right. So just draw a basic picture of this. It doesn't have to be anything perfect. Put your test statistic on there somewhere and then shade going the right direction. Since this was a right-tailed test, we're going to shade to the right of our test statistic. Then we want to find the area of that shaded region, and we're using the chi-square distribution with n-1 degrees of freedom. So you can use the chi-square CDF function on your calculator. And we're going to have the test statistic for our lower bound, a big positive number for our upper bound, and since our n was 60, that means our degrees of freedom is 59. So we get an answer for the area of 0.1437, and that's our p-value. Again, we don't need to multiply by 2 in this one because we didn't have a two-tailed test. Okay, and then the last two parts of this are step 4b, where we find the initial conclusion in terms of the null hypothesis, and step 5, where we state the final conclusion. So let's look at some examples of this. So the test we did about the weight of the airline passengers, we found a p-value of 0.0213, and our significance level here was 0.05. So we want to compare those two using this inequality. And the p here stands for the p-value. There are lots of different p's in all of this stuff, so this one has to do with the p-value. And we're comparing that to alpha. So we put the p-value in here on the left side, the alpha on the right side, and then we want to look at this and find out whether it's a true statement or a false statement. This one is actually true because 0.0213 is actually less than 0.05. Since it's true, that means we'll have positive conclusions for the hypothesis test. So our initial conclusion in terms of our null hypothesis is that we do reject the null hypothesis. And then our final conclusion is that there is sufficient evidence to support the claim, and then we just repeat the claim that we stated in step 1. So our claim was that the mean weight was less than 195 pounds. So we're saying there is sufficient evidence to support that claim, and then we just rewrite the claim again. So for this problem, we found that the p-value is 0.1437. Our significance level is 0.10. So we're comparing those using the same inequality again. So if we put the p-value over here and the alpha over here, then we want to evaluate this and see if it's a true or a false statement. This one is actually false because 0.1437 is actually greater than 0.10. So in this one, the p-value turned out to be greater than the alpha. That means that we have negative conclusions for the hypothesis test. So if this inequality turns out to be false, then you have negative conclusions. So our initial conclusion in terms of the null hypothesis is that we do not reject H naught, or another way you can say it is that we fail to reject H naught. And then our final conclusion is that there is not sufficient evidence to support the claim that the standard deviation of the can volumes is more than 3.2 milliliters. And again, in both of these, the negative conclusion here means that we use the word not, here means that we use the word not. Or in this one, instead of saying do not, you can also say fail to. Either one of those has a negative connotation.